All right, so let's get started. Today we're gonna get into sectioning techniques. Of course, so for your 201, okay, so in this chapter, we will focus on sectioning techniques. They are one of the most important tools in engineering, drawings, and of course, GD&T. So the big idea here is very simple. We want to see inside of a part without guessing about it. Okay. Um, so in real engineering drawings, the hidden lines can quickly turn that drawing into a mess. So section views is going to solve that problem, yeah, by cutting through the object, at least on the paper, of course, so we can clearly see the internal features like holes, slots, ribs, and the cavities of the object. Um, so industry, they expect technicians and engineers, to read section views instantly. You gotta know, immediately. So no hesitation, no confusion. So if you misread a section, parts get machined, okay, wrong, and your assemblies don't fit. And of course, money gets wasted, and that's what industry doesn't want. Doesn't want, they would do everything they can to avoid that. All right, that situation. So in this chapter, we're going to learn by section views, of course, we're going to learn why section views are used, how section views are created, and of course, the different types of sectioning techniques you're going to see, on the professional drawings. Think of it like sectioning, think of it like a X-ray vision for engineering, okay? So that's what we are developing here in this chapter. All right. So we have this, every chapter, of course, your objectives. So before we dive into example, let's talk about what you should be able to do by the end of the chapter. So first, you'll be able to explain what a section view actually represents. So this is not just a picture or a diagram, okay? It's a very specific way of showing an imaginary cut through a part, so your internal features are clearly visible, okay? So next, you're gonna learn, of course, how to identify and apply full, half, and offset sections. So each of these has a different purpose, and of course, choosing the wrong one can make a drawing misleading. Yeah. So focus on we will also focus on correct cross-hatching rule. Yeah. So cross-hatching is not decoration here in engineering drawing. It communicates material and of course cut surfaces. And there are strict standards in GD&T and engineering drawing, okay, for how it's done. And you want to learn how to use align sections, okay, for revolve features, especially for parts like shafts, your spokes, and angle holes, of course, where straight cut doesn't tell the story, okay? And of course, we will cover sectioning rules, okay, for standard hardware and assemblies. Things like your bolts, your nuts, your washers, your shafts, because many of these parts are not sectioned, even when, when the cutting plane passes through them. So by the end of this chapter, well, you should be able to look at a drawing and of course immediately you understand what is being cut, what is not, and of course why. Okay. All right. Uh, Now let's take a look at what is a section view. Let's answer some core question like what is the section view? Well, this view shows section view is nothing. Okay, it shows an object, and after you did a imaginary cut on it, so the imaginary cut has been made through it, and nothing is actually cut in real life. This is like how like you're looking it with your mind, of course, and with your graphical tool, to understand the inside of a part. So we draw that way. So when we create a section view, we usually assume that all material, in front of the cutting plane is removed. Um, of course, like this. So we're basically, peeling away the front portion of the part so we can look directly at, what's inside. Once that material is removed, so here we're removing along this line, okay? So that is your cutting plane line in this example, of course. So, uh, once the material is removed from the front, your internal features become visible, as object lines and not hidden lines. Okay. So now the internal features are now exposed here in this example. That's a big deal, You can see the whole slots and cavities. And they were, of course, once buried inside the part. Okay, now you can see very clearly. Yeah. Of course, the result is the section views reduce hidden lines and confusion because we cut it so the lines inside not exposed and we will be drawing them as visible lines. Okay. Um. Of course, instead of guessing what's happening inside the part, now this type of drawing tells you exactly, what's inside. So on the right side, like here, of course, of this slide, you can see the concept of cutting plane, okay, here. And then, of course, the resulting section view. So the cutting plane, okay, shows where the imaginary cut happens. And of course, your section view here shows what the part looks like, after that cut, of course. So one important thing that you need to remember, right, is that the cutting plane is theoretical, this line right here. And no saw blade actually turns and made the cut. It is pretty much in your mind, okay, you gotta do. And of course, this is about clarity, not a real cutting, the metal, not really cutting the metal. We're doing it all in our head, okay? Cross hatching rules. So let's take a look at it. Um, well, these are critical, yeah, in drawing because this is where a lot of students they lose points in exams. So first rule is, only hatch solid material that is actually cut by the cutting plane. Okay, that's your first rule. If the cutting plane doesn't pass through a solid material, it does not get hatched. All right. So remember that rule very carefully. Of course, second is do not hatch holes or voids because holes, slots, and cavities they represent empty space. So empty space, it never gets cross-hatched. Okay, you gotta leave it alone. Even if it is inside a section view don't cross hatch. Of course, you pay attention to hatch angles, yeah. The typical hatch angles you're gonna see are like 45 degrees, 30 degrees, or 60 degrees. Okay, so these angles are were chosen for clarity and definitely not for your decoration. Okay. So another important rule is here, and that is the same part must use the same hatch style across all views. Okay, so if a part is hatched at 45 degrees in one view, then it stays that way in every section view of that part. Okay, remember that this you can miss it very easily. All right, finally, your assembly, of course. So in assemblies, different parts may use different hatch angles. So it's gonna help you visually separate one part from another, yeah, when multiple, of course, components are cut in the same section, right? Um, so basically your bottom line is, cross hatching is for communication. Yeah, all right, strictly communication. And if it's done wrong, then the drawing is no good. Okay. All right. So here you can see the cross hatching patterns by materials are listed very organized. Okay, so this slide, well, these patterns, they were used to indicate material type, okay, directly on your drawings. Like if you use like aluminum, brass and cast iron, plastics, of course, concrete and steel, you're gonna follow these patterns. Okay, so aluminum is this, of course, brass or bronze is this, so and so all the way to steel. Yep. So you notice here the cast iron and general use hatching looks like simple. So your cast iron is here, yeah. General use, of course, it looks pretty simple. They're like evenly spaced diagonal lines. Okay, so this is the most common pattern you're going to see in modern drawings. And of course, it is often used even when the exact material isn't really critical. Okay, so other materials, of course, like your plastic, look at this fancy, huh? And then, of course, your rubber, here, okay? Insulation. Okay. We even have like ground. Okay, your earth, your dirt is like this. Look, they have like more specialized patterns. So these exist mainly for reference. Okay, and of course for situations like where material, identification is necessary. Okay, so here's the important modern takeaway is in most engineering drawings today, material is specified, okay, in a node or in your title block, not inferred, from the hatch pattern. Okay. So make sure you remember that point. So that means you are usually not required, okay, to memorize every one of these patterns. So which is required is your consistency, of course, clarity and correct use, okay, of these sectioning rules. So if multiple parts are cut in an assembly, yeah, so changing hatch angle or spacing, yeah, helps distinguish them visually. That's why we use these patterns, yeah, for different materials. So treat this slide like your reference, not a memorization task, of course. So the goal is again communication. Okay, it's not artwork. All right, next. So this diagram, compares, of course, correct and incorrect cross-hatching. Okay, and of course it shows up constantly in your quizzes and exams at almost every university. All right, so let's start with the example. Okay. on the left. So this is a three-piece assembly. So shown in, of course, section view. So make sure you look at, even though the cutting plane passes through all three parts, each part is visually distinguishable. Okay, so this one, that one, of course, that one. The hedge angles, so when you pay attention, you can see different angles. Spacing, of course. All right, they change, so your eye can separate one, of course, component from another. So now look at the example labeled incorrect. Okay, so here your hedge lines continue straight across the band as if the entire shape were one solid piece. Okay, so this visually tells the reader this is a single part, okay, which is wrong. So on the right side, okay, is the correct example. Even though the shape is continuous, the hatch lines change direction, okay, to follow the geometry of your cut surface, okay. It's not parallel to this edge here. Incorrect. See, like how the cross hatch lines are not at an angle, but it's parallel to the edges. So here you can see, the hatched line change direction to follow the geometry of your cut surface. So this tells the reader how the material is actually oriented and cut. Okay, so the key rule to remember here, your cross hatching must communicate part, boundaries, and of course geometry. If your hatching makes separate parts, okay, um separate parts look like one or hides the shape of the cut, it's incorrect. Okay, something like this. So this is not about the style, okay, not to make it look nice. It's about making sure your drawing tells the truth. Follow, look at this. Just make sure that you draw correctly, like, the hatch lines change the direction. And of course, you have to follow, change the direction, meaning like it is at an angle, see that, to this two edge in this example, of course, and that's because we want to follow the geometry of your cut surface. It is showing you the cut surface is right here, and we're not like drawing parallel, of course, to the edge lines. Okay. All right, so full section AA. The diagram is in the next slide. Okay, so now let's talk about a full section. Uh, we usually label something like this. Okay, that's just showing you example how to label it. So a full section is we draw like that when the cutting plane passes completely through the entire object. All right, so we imagine like slicing the part in half and then removing everything in front of the cutting plane, expose it. Okay, so we use a when do we use a full section? Let's think about it. So we use it, to clearly show the internal features. So when we want to show the internal features, we use a full section so we can see the whole slot steps, right? And of course, the internal cavities, if any, exist in that part. So full section is also used to eliminate most hidden lines. Instead of cluttering the drawing with all the dashed lines, we replace them with solid object lines, your visible lines, of course, that are much easier for us to read. Anyway, so very often the cutting plane passes through the center of holes or symmetrical features. So this gives us the most accurate and of course the informative view of the part. Okay. All right. So as a rule of thumb, You have to remember full section is your default choice unless we have symmetry or layout, yeah. And if the symmetry or layout suggests another type of section would communicate the design better, then we're gonna use some other section, okay? Uh, types. So if your goal is for clarity, full section, okay, is usually the right choice, okay? All right, so let's take a look at this picture diagram. Um, this is a full section example. So you can see how this works in practice, real world part. So at the top of the figure, you're looking at the original view of that part with the cutting plane on it. So that dashed line, yeah, running across it is your cutting plane here, yeah. And of course the arrow shows the direction, yeah, uh, of sight. So this tells us which way we're looking after the cut is made. Okay, so the cut is made that way, and you're cutting down, by the way, okay, cutting straight into the page. Don't forget that. And then we are gonna look at it after cut expose and you look at it. So make sure you notice that the cutting plane passes completely through that entire part, yeah? So right through the center of the internal features and we open it, yeah? So that's the key requirement for your section view. So now, I mean full section view, okay? So now look at the view here below. So this is the resultant full section view. So everything in front of the cutting plane has been removed, okay? And the cut surfaces, of course, are cross-hatched, okay? At an angle to the edge, yeah? So the internal features, see, look at that were hidden before, like the central hole right here, of course, the internal steps right there are now, you can see them very clearly. Yeah, and we use a solid object visible lines, yeah, instead of the hidden lines here. See that? All right, so make sure you also notice what is not hatched. So holes right here, empty spaces, yeah. We have to leave them blank, because only solid materials that's actually cut gets cross-hatching, okay? So this example here shows you why full section, sections are so powerful, the part becomes much easier to interpret. Yeah, and of course, there's far less chance of misreading the design. Okay, so that's why we do full section view. All right. Now let's look at this manual steps for creating a full section. Yeah. So this is exactly how you should think when you're doing this by hand or in AutoCAD or some other CAD software. Okay. So first you choose the cutting plane location. You want it to pass through, okay? You want it to pass through the most important internal feature. So usually through the center of holes or symmetry. All right, so that's what first thing I wrote to here. So next you're gonna draw the cutting plane line with arrows. Okay, so the arrows very good because they show the direction you're looking after the cut is made. Yeah, so your orientation matters here. Of course, then you're gonna label the cutting plane AA, yeah, A-A. So that label is just a formatting, okay? So that label connects your cutting plane to the section view so that you are about to draw. So after that, convert, any revealed hidden lines into object lines. visible lines, of course, object lines. So once the material is cut away, those internal features are no longer hidden, so they become rear edges. Next, you're gonna hatch only the solid areas, that are actually cut. Do not hatch holes, do not hatch slots, do not ever hatch empty spaces. All right, so finally, so the last one, make sure you title the view section AA so the reader knows exactly what they are looking at. So if you follow these steps in order, your section views will always be clean, will always be readable, and will always be, industry correct, I would say. Okay. All right, so now let's talk about how this translates in AutoCAD. Because we are using AutoCAD here in this class, of course. Of course, you can use AutoCAD like software to do drawing. It doesn't really matter. Anyway, so because the workflow matters in AutoCAD, So first, you're gonna draw your parent views first, and then of course, always get your standard orthographic views correct before you even think about sectioning. So check, make sure you check your ortho. And then you're gonna add, of course, your cutting plane on its own layer. Don't forget your layers. So that's gonna keep your drawing really clean, and then it is gonna make it easy to turn the cutting plane on and off when you need it. Then of course, project the section view from the parent view. Um, so don't redraw it freehand. Make sure you project it so everything stays aligned and everything stays accurate. Okay, so after that, you're gonna apply your ANSI, your ANSI 31 hatch pattern. So that's the standard general purpose section hatch used in industry, unless otherwise is specified in your instruction. So once the hatch is applied, you're going to trim the hatch out of holes and voids. Okay, so trim hatch from your holes. Remember, holes are empty spaces, so therefore you should never hatch them. So finally, here is your quick check. This is important, so there should be no hidden lines inside hatched areas. Make sure you are aware of that. So if I ever see hidden line inside a section hatch area, that's a hard stop because it means the section rules weren't applied correctly. You're not going to get your grade. So if you follow this workflow, from here to here, your section views will always be clean, will always be readable, and will always be ready, for grading. And of course, don't forget it's gonna be good for your industry use. All right. I'm repeating myself again and again so you get it actually. All right. Now let's talk about half section. Um, of course we use they're used for symmetrical parts. So you use a half section when the object is symmetric. Okay, you want to show both internal and of course external features in a single view. So you know, uh, because this is going to save your space, and also it's going to make your drawing easier, to read. So in half section, one half of the view is sectioned, showing this is kind of like a view a rule, okay? So showing the internal features with cross hatching, and the other half is left as an external view. It's kind of like exposing only half. So showing the outside shape. So here your key rule, I wrote it here so you kind of remember when you deal with your half sections. So this is very important, So the dividing line between the two halves is a center line, okay? It's important. Your dividing line between the two halves is a center line, and that is not an object line. Okay, always remember that. most of the students they forget that, yeah. So that center line represents the axis of your symmetry. We're dealing with the symmetry, so you have to have a center line, yeah, that is showing the axis of the symmetry. So if I don't see the center line in half section, yeah, you're not going to get your grade. So if you draw a thick object line there, the drawing is incorrect, yeah. So when we do a quality check, those are the things we try to spot, okay? So half sections are efficient because one view does two jobs. So it shows inside and of course outside at the same time, but only when the part is truly symmetric, okay? So you have to remember that if the part is not symmetric, you should not use, all right, a half section. All right, now let's see half section example here. So you can see how the rules are applied. So at the top, you see the parent view, right? And it is a symmetric part. So your cutting plane line here passes, all right, straight through the center of the object here. Your object is this thing right here, yeah? Um, Along this, of course, your center line, okay, is going to be right here. Yeah, I'm trying to show you where the center line is. Yeah. So the arrow, of course, is going to show the direction of the sight for the section view. Yeah, so we are looking after cutting, we're looking at the object like this way. So now look at the view below, okay, which is this guy. So this is your half section. So on one side of your center line, the part is section. Yeah, so we can see the internal features very clearly, and the cut solid areas are cross-hatched, okay? So on the other side of this center line, we see the part is shown as an external view, so with no hatching on it. So this shows the outside shape at the same time, okay? So make sure you pay close attention to the dividing line between the two halves, yeah? So that line is the center line we talked about. Yes, it is not a visible, okay, object line. So that tells the reader this part is symmetric. Okay, so also note that the holes are not hatched. Okay, so holes are left empty here. So even though they appear inside the section, inside this half section, of course. So this example shows you why half sections are, so effective for symmetric parts. One view, of course, it communicates both inside and outside features cleanly and, of course, efficiently. Okay. All right, now let's go over the rules you must watch, okay, when creating a half section. So because this is where mistakes usually happen. All right, so first, exactly half the view is hatched. So that's your first rule. Not more, not less. If you have like more than half is hatched, it's no longer a half section. Second, you have to know that your center divides the two halves. Yeah, so that center line represents symmetry. Center line is symmetry. Center line is for symmetry. It is not an object edge because there is no physical edge there. Yeah. Now the third, all right, your thin ribs, of course, your spokes are usually not hatched, even if your cutting plane passes through them. Yeah, don't hatch it. Hatching those can misrepresent thickness. And of course, it's gonna definitely cause you confusion. Yeah. And and the next rule is hidden lines may remain in the external half, yeah, of your view, of course. So that's totally allowed because that side is still a standard external view, yeah. So and here's the big thing that you need to remember, like big warning, yeah, something that you don't want to mess up is don't draw a thick object line down the middle. Okay, never do that. That would be incorrect. That would be wrong. So no physical edge exists there. Yeah. So using an object line is completely wrong. Yeah. So if you remember these rules, we're done GD&T here. Yeah. 201 is different from 101. 101, we're just concentrating on shapes. Yeah. Here we're concentrating on the rules. Do it and not doing it. Okay. So all these rules. So your half sections will be cleaned, correct, and easy to grade if you follow these rules. Okay. All right, now we're gonna look at offset section. All right, so which are used when a straight cutting plane, all right, just won't work. You use an offset section when important internal features are not aligned in a straight line. Okay, and this is really very important. So I can explain that like if you have like a single straight cut, all right, so in if that single straight, all right, cut is gonna miss key holes or features, we don't give up. We're gonna offset the cutting plane. Yeah. So in an offset section, your cutting plane jots, all right? So it jots means it changes direction. Of course, to pass through multiple, important features. So you're going to see those jots clearly in the cutting plane line on the parent view. Okay, so the diagram in my next slide and I'll show you. So here's the key rule, and this one is critical because the jot lines never appear in a section view. Yeah, so make sure you remember that. So even though your cutting plane bends in the parent view, the resulting section view is drawn as if all those features lie in a single straight plane. Okay, so make sure you remember that. So think of it like your cutting plane can bend, but the section view is gonna stay straight. Okay, so once you understand the idea, your offset section becomes much easier, yeah, to read and also to draw. Okay. Section in section views, offset section maybe a little bit difficult for you. So make sure you review your 101, okay, level one. All right. So let's walk through this offset section example, and we're gonna do step by step. So on the parent view, okay, uh, notice the cutting plane line, yeah, here. It's not straight. See this jotted like that? Jumps, yeah, so it jots to pass through multiple important feature. We jog because we need to go through this, and that, okay? So that's why we jog. All right, so it jogs to pass through multiple important features, like the holes, right, that are not aligned. So this hole and that hole, they are not aligned with each other. And that's the reason why we have to do the offset cut, yeah? So the jots are intentional, so they allow the cutting plane to capture all the critical internal features, yeah, in a single, of course, a section view. You want to do only one cut. You don't want multiple cuts. Yeah, just a waste of time. So instead of forcing you to cut multiple section, you have to draw multiple. We don't have time for that. Yeah. So now look at the section view. Label, of course, section DD. Here in this example, even though the cutting plane bends in the parent view, your section view is drawn as a straight line. Yeah. So continuous section. Of course, there's no indication in the section view that your cutting plane change a direction. So you wouldn't know how this jotting is going on. Yeah, your jogging is going on. Of course, so this is the rule that like trips many people up because your jot lines never appear in the section view. You have to relate to the parent view here. So the hatch pattern is continuous and your features are aligned as if they lie in one single plane. Yeah, that tricks you. And of course, the drawing stays really clean and routable if we draw like this way, okay? And make sure you remember offset section band in the parent view, but they are straightened out in your section view, okay? Little things that you don't remember, yeah, in METL 101. Okay. All right. I have to go slide by slide and I have to rest a little bit, yeah, because it's just taking my voice. Anyway, so this slide shows the classic mistakes students make, yeah, with offset sections, of course. So if you draw the jaws at edges in the section view, that would be wrong. Yeah, so these jots only exist again in the cutting plane line on the parent view. Okay, so in section view, you never show the bands in the cutting plane. Yeah, so you can see the jaw inside the section view. The section would be incorrect. Yeah, so the correct approach is project the features. Yeah, project the features as if the cutting planes were straight. So you realign these features so they read cleanly in one continuous view. Okay. So remember this rule, yeah, always offset sections band in the parent view, not in the section view. They don't band in the section view. Okay. So if you keep that one sentence in your head, you will avoid the most common offset section error. Okay. All right, now let's look at aligned section. Next one. So which are they are used for like revolve features. Okay, so aligned sections are commonly used for spokes, your ribs, and your webs, all right, features. So these features are like arranged around a central axis, usually on round or cylindrical, okay, parts like that. So why do we need a line section? Let's see. Because with normal projection, these features can look really distorted or or misleading, of course, when they are shown at an angle. Yeah. So in an aligned section, the feature is rotated into the cutting plane. Yeah. Before the section view is drawn. So we rotate in. Of course, the rotation is conceptual. You do it in your mind. Yeah. You're not changing the part, you're changing how it's represented, yeah, in your drawing. Do it in your drawing. We don't do it physically outside. So by rotating the feature into the cutting plane, the shape and the thickness of the rib or spokes are shown clearly, okay, and of course accurately. So this is standard drafting practice, and of course it's going to help prevent misinterpretation of angled, of course, or curved, okay, features. So make sure you remember line sections, yeah? They are about clarity, okay? We make the revolve features readable without distortion, okay? All right, let's take a look at this example. So look at this align section, okay? So you can see like how the concept works in an actual drawing like this. At the top, you're gonna see your parent view, yeah? It is a circular part with revolved features. Yeah, these are the revolved features. So like your spokes, yeah, here, of course, ribs like that. Arranged around a central axis is right here. So make sure you notice that one of those rib is aligned relative to the cutting plane. Yeah, here is your cutting plane and it is aligned, one of those. Okay, rib here. And your cutting plane, of course, here we label AA, yeah, passes through the axis of that part right here. I'm showing you, yeah, one by one. So if we used a normal section here, the aligned rib would appear distorted, okay, or thinner than it really is. So we cut it like, like that, of course, and then we look at it like this, yeah? And we will be using the aligned section, of course. So what do we do in the section view? Yeah, this is your section view. The revolve feature has been rotated, yeah, into the cutting plane. So we rotate it into the cutting plane. So this rotation is really happening in the mind, yeah, not physically. So we're not changing the part, we're changing how we draw, yeah. So the feature's true shape is visible, yeah. So we can be able to see the feature true, of course, shape there, yeah. So that's why the rib in the section view looks straight and of course correctly proportioned, even though it was aligned, yeah, in the parent view, of course, like that, yeah. So here is pretty much a line, but see like how we rotate it into it and we draw it that way. Okay. So the key, of course, the key point here is your align section, straighten the revolve features so they can be read, okay, clearly. Yeah, we can be able to read it clearly. So this is standard drafting practice. Yeah, very important for GD&T, and also going to prevent misinterpretation of thickness. Yeah, and of course your geometry. No, let's see the rules. GD&T has a lot of rules, so be very careful. Now let's go over, yeah, sectioning rule for your of course, a section. So because these are easy to forget if you're not very careful about them. So first, rotate the feature conceptually, yeah, so into the cutting plane. So this rotation is again in your mind, yeah, it's done for clarity, not because the part actually moves. Then remove any construction geometry used to show that rotation. So the finished drawing should look clean and intentional, not like a sketch in progress. Okay, so here's a critical rule: do not hatch ribs or spokes that are cut longitudinally. Okay, so make sure hatching them is not good. Yeah, so hatching them is gonna make those features look like thick blocks, and that is gonna misrepresent the part. Yeah, so instead hatch only the surrounding material, which is your solid material that is actually cut by the plane. Okay, so this rule exists to protect the clarity. So when ribs are shown correctly, their thickness and functions are immediately obvious. Okay, so if you remember nothing else from aligned sections, make sure you remember like rotate for clarity, hatch only true cut materials, and never hatch longitudinal ribs. Okay. All right, next. So now let's talk about the hardware, yeah, in section view, because this is a very common mistake, yeah, people do. In our industry, of course, in section view, standard hardware is not hatched, right? Standard hardware do not hatch. So standard hardwares are, I list them here. So your bolts, nuts, yeah, your screws, pins, and washers do not hatch. Of course, even if the cutting plane passes directly through them, you do not hatch the standard fasteners. Why? Because the parts were cut first, and then your hardware was added later, okay, during the assembly. So the section represents cutting the machined parts, not slicing through the bolts and the screws, okay? So this is really, really important. So this is also about realism. So in industry, nobody section bolts and drawings, yeah? Nobody section screws. So if you hatch hardware, it immediately signals that the drafter doesn't understand GD&T. Yeah, the drafter doesn't understand assembly conventions or the rules at all. Yeah, so we pay attention. So remember this rule very, very clearly. Standard hardware stays unhatched in section views. So if you hatch bolts, machinists will absolutely notice and they won't be impressed. Okay, they will make issue out of you. All right, next slide. I'm going slide by slide recording. Okay, so here, let's look at this. This is an example, yeah, example of a hardware shown correctly in a section view. So notice that the surrounding solid parts are cross-hatched, yeah. So because they are the parts being cut by the section plane. Now look at the bolt and the screw, of course. Yeah, fastener running through the assembly. So even though the cutting plane passes through, yeah, passes right through it, the hardware is not hatched. Yeah, we leave them alone. So that's very intentional and that's correct. Yeah, so the hardware is shown with visible lines only, while the matched parts around it are sectioned. Okay, with section, no, 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 no here. Um, so this clearly tells the reader what is part of the base material and what is standard hardware added during the assembly. Okay, so this is exactly how section assemblies are shown in a professional drawing. Yeah, so if you match this visual pattern, yeah, hatch parts and hatch hardware, you're doing it correctly. Yeah. All right, now let's lock in the rules for assembly section views because this is where students most often lose points. So first, structure parts are hatched. Any part that is actually being cut and is part of the main structure is gonna get hatched, okay? It's gonna get cross-hatching. So second, your hardware that is cut longitudinal is not hatched. Your bolts, your screws, your pins, they're gonna stay unhatched, even if your cutting plane passes through them. Yeah, do not hatch. The third one is when you have like adjacent parts, you must vary the hatch angle. Yeah, so this is how we usually separate different components in an assembly. Yeah, so same angle means same part and different angle means different part. Finally, of course, keep hardware center lines very visible. So center lines help communicate alignment and function, and of course they are going to stay even, in the section views. So if you follow these rules, these four rules, golden rules, your assembly sections will read clearly, and of course they look like professional manufacturing drawings. Okay. All right, let's take a look at your common grading errors, yeah, for chapter 3, of course. So before we wrap up this chapter, we're gonna go over the most common grading errors, yeah, I see in section views. First, hatching holes. Hatching holes, be careful. So holes are empty space. So if you hatch them, that's an automatic grade deduction. Second, drawing jot lines in offset section views. So the jot, all right, the jot shows where the cutting plane turns. So, but it never appears in the actual section view. Yeah, be careful. The third one, using an object line instead of a center line in half section. A lot of people do that. Make sure you don't do it. So the dividing line must be a center line. Yeah. A thick line implies a physical edge, and that edge does not exist, okay, in the symmetry. Of course, number four is going to be hatching bolts and washers. So standard hardware is not hatched. So if I see hatched bolts, I stop grading there, yeah? Okay, so and finally, your random hatch angle changes. So hatch angles only change to distinguish adjacent parts, yeah, not randomly. So make sure you apply to the adjacent parts and change, all right, the angles. So if you avoid this five rules, I would say, yeah, don't do this five mistakes, okay? You will protect most of your points in chapter 3 drawings, okay? Right, be patient. We are yes, at the summary page right now. So let's wrap this up. Remember, your section views exist to replace hidden lines, yeah, clutter. We're getting rid of hidden lines, replacing them with visible lines. So instead of guessing what's inside a part, we cut it up and then show it clearly in our drawings. Different section types solve different problems. Okay, so have full section review everything along a cutting plane. Half sections are ideal for symmetrical parts. Offset section let us capture features, yeah, that don't line up. And of course, a line section is gonna help us clarify the revolve features, yeah, like your ribs and your spokes. Hardwares. So hardwares, make sure you follow, yeah, special sectioning rule. Structural parts are hatched. Standard hardware are not hatched. So that distinction, you have to be careful. At the end of the day, okay, make sure the correct sectioning communicates your manufacturing intent, yeah, what you want to say to the manufacturing shop floor. So machinists over there are they should be able to look at your drawing and they should be able to understand exactly what to make, how parts fit, and then of course what matters. Yeah, we have fit issue, like destroy lives of many people by the way, okay? So you don't want fit issue. You don't want to lose your job. So anyway, so that's the goal of section views. Yeah, and of course that's the standard you should be aiming for in your drawings if you want to stay in this industry, okay? Of course, this is my usual work for you, reminding your homework. So your homework, make sure you complete your assigned section. Okay, exercises listed in your textbook. I put it all everything in the textbook for you, so we won't have any kind of confusion. Okay, I'm tired of this stuff like every semester. So now we make a book for you. So yeah, all right. So you are required to draw the correct section views. Um correct, section views, which may include full section, half section, of course, offset section, align section. Yeah, so make sure you use whichever type is appropriate for the part. Okay, make sure you apply your proper, yeah, the cutting plane lines, of course. Make sure you labels correctly. Include your arrows, section identifiers. Yeah, very important. Make sure you use your correct cross hatching rules. Do not hatch the holes. Do not hatch the standard hardware like bolts and washer and nuts. Make sure you follow the line type. Yeah, your line type standards very very carefully. Your object lines are called visible lines. Yeah, your hidden lines and your dash line is your hidden lines. Your center lines uh make sure all these lines are correctly labeled, not labeled, I mean correctly drawn, okay, because they all matter and it will be graded. And of course, finally make sure you submit your drawing exactly as instructed, okay. I already gave you what to submit and where to submit and when to submit on Brightspace, so make sure you follow Brightspace, okay. And of course, accuracy is very important in our industry. So accuracy matters more than the speed here. Yeah, we don't want a fast job or quick job. Yeah, we want a accurate job. So make sure you clean Your correct sectioning, yeah. I want a clean and a correct sectioning, and of course, this is gonna earn, yeah, the best points. All right, so we're done with chapter 3. Yeah, this is just identifying the source because we're required to do it. Yeah, I have to put my face too. I don't like putting my face when I record. It's just annoying. So I just now, use Zoom and stick this thing right there for you. So you know that who is talking is me. All right, let's start right there.